This is part 8 of the Permanent Magnet Synchronous Motor Control series with Professor Duco Pule, Hardware in the Loop application for motor identification.
In any encodance application, you need to identify the parameters. So in the permanent magnet machine, you need to identify the inductance and the resistance and the flux. And there is a unique routine here, which the algorithm goes through, which will take you through the steps in about 50 seconds. And in InstaSPIN, we show the current, the speed, the inductance, and the various states which appear as we go through this, and we analyze it during the course. Again, it's a separate module which does that. And that process is done for can be done for any machine. So we can run that here, and then download it, make sure the converter's off first. And just check on the voltage. This is the most advanced stage, really, and it's not just for PM machines, but it also works for induction machines. So we have the voltage, and now what will happen is that as soon as I hit the button, and I've set recalibration off, online, off, and if I now switch on the converter, there will be, which is what I'll take a full 3 hours to discuss, the various modes of operation which occur as it steps through the identification process. And it identifies the gains for the current controls, it identifies the resistance of the machine, which is happening here. And then it will speed the machine up, ramp up, and identify the flux of the machine, which is happening here, at this level. We're now stage 4. And then it moves to the next stage, which identifies the inductance of the machine, which is this one here shortly, which is this level here. Current increases, inductance is being measured here. So now it measures the inductance of the machine, which is what you see happening here. That's the inductance coming back to a steady state value, and then it switches off. So the whole process is identifying the gains of the current controller, identifying the resistance, identifying the flux of the machine, and it does it in less than 60 seconds. And most machines you will encounter will do it in 60 seconds. And not only for the PM machine, but also for induction machines. Now that process is made possible by doing this type of work in analysis in VisSim, where I can look at the peak current amplitude, I can look at the estimated speed, for example, I can look at the inductance estimation, and I can look at the control states as the algorithm steps through its identification process. It is that type of level. And if things fail, and things often or can fail depending on the machine, on how the parameters are set, things will fail, but at least you can see where things go wrong and make the adjustments accordingly. But what we explain exactly is what happens at every phase during every of these estimated states. Because 60 seconds is quite small. So it is that process which you need to understand for the machine, so you can take it successfully through this cycle and then achieve the best control. So, and the parameters you need to set here are set here. So these are some of the parameters for setting up the identification. The other parameters here are the ones we set up for doing fast by itself, which we did in a previous presentation. So really, it comes down to encoder's control, any type of machine, PM, non-salient, but also stepping motors is another option. Two-phase machines, single-phase induction machines, any machine can be done in a very short time. And that's the power of VisSim, really, without getting into the nitty-gritty of C code. Keep your top-eye view at all times, because that's the only way you're going to get an optimum design out there fast.